Okay. Good evening, all two of you. Let's fix this work. Thank you. So we had just done series convergence. Right. Now the goal of that was to get up to representing any function as a power series. Of course, when you're dealing with functions, you have domains. So a power series is also going to have a domain called its interval of convergence or its interval of definition. Power series, any series of the form a sub n times x minus x naught to the nth power. Right? A sub n is just some general term that we have, right? So we've been working with general terms already. X naught is the center.
X minus x naught?
That's x minus x naught up here, yes. Right, so x naught some constant. X is an independent variable. So look what this says. This is a polynomial, right? So every function can be represented as a polynomial. Now, how are we going to represent it? Well, I get into that next time. There is a method. There's one specific power series that's guaranteed. But the general idea is if you know the power series, you can approximate functions as polynomials. How good do you want your approximation to be? That determines the degree that you're going to use. Right? So the power series goes up to infinity, right? So if you want really good approximation, maybe you want a 10th degree polynomial. So once you know, for instance, the power series expansion for sine of x, you could approximate, let's say, sine of a half by using its polynomial, the polynomial expansion, the power series expansion. Now, again, this is only going to be good if your point is close to the center, right? So that wouldn't be good. So sine x power series is usually centered at 0. Sine of 3 wouldn't really be a good approximation there because it's kind of far away from the center. I mean, you could still do it, but you're going to need a much higher degree polynomial. And this idea comes in handy if you're given a data point, right? So you have a list of data and you want a curve approximation for it. Typically speaking, the idea is you find a polynomial approximation. It's called a polygonal approximation. And that's usually the curve of best fit. That's a numerical analysis course. You'll study that if you take numerical analysis, which is a junior level math course. So as I said, every power series expansion has what's known as the interval of convergence. Or the interval of definition. Power series is guaranteed to converge over the open interval x naught minus r to x naught plus r. R is called your radius of convergence. And we'll be figuring out how to find that throughout the problems. It may converge at one of or both of the endpoints. So once we find the open interval, we have to check the two endpoints to see if the series converges at the endpoints. It may not. The power series is always guaranteed to converge at x naught. There are two special cases for the radius. Radius of 0, which would mean your interval of convergence is actually just a single point, x naught. The other special case is you get a radius that is infinite, in which case your interval of convergence is just all real numbers. Our focus this evening is going to be finding the intervals. Here we have power series, x to the n over n squared. Find the interval of convergence. Well, we have a very useful tool for this already. Let's take a look at this limit. The n plus 1 term would be x to the n plus 1 over n plus 1 squared. Now times the reciprocal of the n term, which is just n squared over x to the n. Simplify this. X to the n plus 1 over x to the n. How does that simplify? It's just x, right? What about n squared over n plus 1 squared? Now remember, for this limit, n approaches infinity. Right? That's implied. That means for purposes of this limit, x is a constant. So we can factor out an absolute value of x. N squared over n plus 1 squared is always positive, right? So we can get rid of those absolute values. This is what we're left with. What's that limit? It's 1, right? So we're left with the absolute value of x. Where did this limit come from? Right? Because it's not a limit I just pulled out of my ass. We looked at it Monday.
Oh, the ratio test.
It's the ratio test. When does it converge according to the ratio test?
Less than
When the limit's less than 1. So if this power series converges, we want that limit to be less than 1. So the absolute value of x needs to be less than 1 to converge. But remember, the ratio test also said if it equals 1, it was inconclusive. It could converge or diverge, which is why we need to check the endpoints. There's another way of writing absolute value of x is less than 1. Do you remember the interpretation of that from pre-calculus? when you studied the absolute value function. You also should have studied these interpretations in algebra when you're looking at solving absolute value equations and inequalities. And one of you had me for pre-calculus, so you better know this.
Well, would it be that x is less than 1 and negative x is less than 1?
You were correct the first time. Negative x is greater than 1. That is true.
X is greater than 1, and
Wait, no, I'm sorry. Negative x is not greater than 1. Less than 1 would be correct.
negative x is less than 1.
Yes.
But positive x is greater than 1.
Would also be less than 1.
Oh, so they're both less than 1. Okay.
So what does that mean? You can write it this way.
Yeah, it's between negative 1 and 1. Yeah.
That's the interpretation. Those are the endpoints of the interval, -1 to 1. What was x naught for here? So what was the center for this power series?
0.
0. What's the radius then?
1.
The radius of convergence here is 1. That limit was 1.
How do we know that x naught was 0?
X minus x naught to the nth power.
Okay.
We just have x to the n, right? So that's what, x minus 0?
Yeah.
So x naught 0. That is not enough to make a conclusion about the radius just yet. But just keep that in the back of your mind right now. The limit here is 1 and our radius was 1. What we have to do is now test the two endpoints, -1 and +1. Well, that's easy enough to do. Just replace x with -1 in the power series. -1 to the n over n squared, correct? What does that series do?
Alternate.
Right, so converges or diverges?
Converges.
This one converges. Well, I don't know what it converges to, and I don't care what it converges to. I just care that it converges. The actual term itself, yes, does converge to 0. But what the series does, what it converges to, I don't know. That converges by the alternating series test. Right? 1 over n squared, positive, decreasing, goes to 0. So it converges by alternating series test. When x equals 1, one over n squared. 1 to the nth power, of course, is just 1.
I don't think it converges.
Why?
P series?
This is a p series. Specifically, it's a convergent p series. We converge at both endpoints. There's our interval of convergence. Closed interval -1 to +1. Both endpoints are included. Ratio test is not the only limit I can use here. I could theoretically also use the root test. Obviously, wouldn't make sense to do it in this case, but if that was over n to the n, it would make sense to use the root test. Right, and then the analysis would be the same. It has to be less than 1 to converge, and then go from there. So let's start with x naught. What is x naught here?
-1.
In this case, we're centered at -1. And so let's look at the limit of the absolute value of the ratio. How is that simplified? Limit of the absolute value of what?
-1.
Times root n over root n plus 1.
That x plus 1 is a constant. So take it out. Root n over root n plus 1 will always be positive, so we don't need the absolute values anymore. What is that limit?
Also 1.
It's just 1. We wind up with the absolute value of x plus 1. That's going to have to be less than 1. Which means that x plus 1 is between -1 and +1. Or x is between -2 and 0. What does that make the radius of convergence? 1. Oh, the limit was 1. Still not enough to make a conclusion. We need to test the two endpoints, -2 and 0. However, I also want to note that we have x plus 1 to the n in the series. So we could just say this. Let x plus 1 be -1. That'd be the same as saying x is -2, isn't it? Just reduces some of the arithmetic. What does that series do?
Converge.
Why?
It's alternating series.
True. It's alternating. That doesn't automatically mean it converges. Just because it alternates doesn't mean it converges.
Well, Y on top. And then there.
So what do we know about 1 over root n?
It's B.
Positive?
Series.
Well, 1 over root n is a p-series, that's true. But in terms of alternating series, 1 over root n positive, decreasing, converges to 0. That's why it converges. Right endpoint, x plus 1 is going to be 1. What does that series do?
It would diverge
Why?
because it's a P series and on the bottom is the power of 1/2 less than 1.
That is a divergent p-series. So converges at the left endpoint, but diverges at the right.
So right on one region,
So half closed, -2 to 0.
Can you go back to the previous slide real quick, please?
I could.
Okay. Mhm.
Right? What is x naught?
zero.
What is our n plus 1 term?
It would be n plus 1 times x to the n plus 1 over 10 to the n plus 1.
Reciprocal of the nth term.
10 to the n over n times x to the n.
How does that simplify?
So n plus 1 x over 10 to the n, or not to the n, times n. Yeah.
I'm going to leave the 10 in there. It doesn't matter. Actually, for my purposes, it is going to matter. For what I want to observe. What is that limit?
One over 10.
So it has to be less than 1. Which means the absolute value of x is less than 10. -10 less than x less than 10. What is the radius of convergence? 10. What was the limit? 1/10. How are they related?
It's going to be like a couple of intervals excluding the limit point. Is it going to be like 2 intervals excluding the limit point?
So right now I'm just interested, how is 1/10 and 10 related?
I think it's x to the 1 versus x to the negative 1, or
They're reciprocals.
yeah.
Radius was 1. Limit was 1. Aren't they reciprocals?
Yes.
Now we're getting somewhere. Wonder if that's always going to be true. Well, let's do some more and we'll see if that pattern holds up. And notice that the limit that we're taking would be the terms without x. Right? It would be the ratio without including x. That's why I left the 10 in that limit. Because if you just take x out, and you just pretend it's not there, you do the ratio test on that, you get a limit of 1/10. At -10, we get n over 10 to the n times -10 to the n. Simplify that.
Is it negative 10 n to the over?
Minus n?
Close, it's not -n. There's an n. How'd you get just negative?
Well, 10 to the power of n over 10 to the power of n.
True. How'd you get a 10? How'd you get this to be 10 to the n?
It is already.
It's not, because there's a negative in front of it.
Oh, can you like factor out a 1 and then do that?
How would you factor out a, well, it wouldn't just be 1, it'd be a -1, but how would you factor out a -1?
Like if you put negative 1 times n times 10 to the n over 10 to the n,
Not -1 times n.
will it just be negative n?
What does that equal? AB raised to the nth power.
A to the n times b to the n.
What's A?
Minus 1.
What's B? So it should be -1 to the n times 10 to the n, all over 10 to the n. That's why I said it's not just a negative. Right? Another way you could examine that is, since they have the same power, that's -10 over 10, right? All raised to the nth power. Negative 10 over 10 is negative 1. Negative 1 to the nth power. That's the other way you could look at it. What does that series do? Diverges. Why? What's that limit?
Non-zero.
Doesn't exist, so it's not 0. Diverges by the divergence test. Now, if x equals 10, how would that simplify?
So you're going to just n.
Just n. What does that series do? This diverges.
Yeah, because it's equal to 1.
For purposes of this class, it diverges. String theory would say that's negative 1/12. That's not my phone. That's nice. I always dread hearing that sound because it's usually my wife calling. It's never good news. So this power series happens to diverge at both endpoints. All right, so our interval of convergence is just the open interval minus 10 to 10. Right. Again, that means that this expansion would only be valid for values of x between minus 10 and positive 10. What is our x naught?
Minus pi million.
What would it just be pi?
Which one? Minus pi or pi?
Pi.
Pi.
Yeah.
Right. The other one was minus 1 because there was x plus 1, right? So x minus negative 1. All right. Again, generally speaking, this finding x naught is not important when you're finding interval. I'm only stating it to make observations. What is our n plus 1 term?
Is n plus 1 times the quantity of x minus pi to the n plus 1 power over 3 to the n plus 1 power.
Reciprocal of the n term.
3 to the n over n times x minus pi to the n power.
simplify.
X minus pi times n plus 1 over 3 to the power of n plus 1.
Just n.
Okay.
Absolute value of x minus pi is a constant. We're left with that. What is that limit? So a third, the absolute value of x minus pi has to be less than 1, which would mean that the absolute value of x minus pi has to be less than 3. X is between pi minus 3 and pi plus 3. What's the radius? What was the limit?
1/3.
Huh.
Reciprocal.
That's interesting. The radius always seems to be the reciprocal of the limit of the term after removing x. More specifically, x minus x naught. That's only 4 cases where that happened. Not a large enough sample size to make a conclusion. Technically 5 won't be either, but I'm going to suspend disbelief and say 5 will be our sample size. Should technically do thousands as a sample size. We don't have time for that. I'm going to take the shortcut. Pi minus 3 is the left endpoint, which means -3 for x minus pi would be the left endpoint. So just replace x minus pi with -3 in the series. Let's see what we get. N over 3 to the n times -3 to the n. What does that simplify out to?
Minus 1 to the power of n. 1 over n.
And we already saw what that series does. Now for the right endpoint. N over 3 to the n times 3 to the n simplifies to what?
So just n.
And again, we already saw that that diverges. So the interval of convergence is the open interval pi minus 3 to pi plus 3. This one's fun. What is our x naught?
0.
So limit of the absolute value. What is the n plus 1 term?
Would be n plus 1 factorial. And then squared over 2 to the quantity, 2 times the quantity of n plus 1, all factorial.
X is more of n plus
Yeah, that's what that.
So I don't blame you. You forgot your x.
Yeah.
That's a little math pun.
Oh,
Good, he gets bonus points. He at least laughed at my math pun.
okay.
You're probably not old enough to have to worry about forgetting x's. I have too many to count, thankfully. Reciprocal of the n term.
Let's see, 2n factorial, all that over n factorial squared times x to the
Simplify that.
So we have, I think,
n plus 1 squared x over 2n plus 2 multiplied by 2n plus 1.
What is that limit?
1 over 4.
Right? Quarter absolute value of x has to be less than 1, which means the absolute value of x is less than 4. X is between -4 and +4. What's the radius?
4.
And what was the limit?
It's all 4.
Huh. Once again, the radius is the reciprocal of the limit. It is at this point where, and this is how math works, notice a pattern. The mathematician now makes a conjecture.
Does that mean like a problem that doesn't fit the previous patterns?
No, conjecture is an unproven theorem. So you're just making conjecture about
okay.
patterns that you see.
Okay, so like more like a theory.
Well,
Assumption.
theorem is a conjecture that's been proven.
Yeah,
So conjecture is just a guess.
Yeah.
Right? You notice a pattern, so you guess that that pattern always holds. Once it's proven, it becomes a theorem.
Yeah, it's more like a theory.
No, theory is different in math.
Okay. So yeah, like an assumption.
Theory typically would be a field of study. Right, so the best way is, my math major is not here, that makes me sad. Junior level math course, abstract algebra. there's 3 fields that you study in that. Group theory, right? So studying groups. Ring theory, studying rings, and field theory, studying fields. So a theory is just a broad collection. A theorem is a specifically proven statement.
Okay.
Right. So yeah, it's different than science, where you have the theory of gravity, which is a statement about gravity. It's completely different in math. Theory, generally speaking, in mathematics is just I hate to say field of study, but that's essentially what it is. It's a field of study.
Okay.
Right? There's knot theory. You have game theory. Game theory is really fun. Chaos theory. Love chaos theory. You thought math was nice and ordered? Ha ha! Chaos theory says no.
That's a math class, chaos theory?
Oh yeah, that's a field of study in math, chaos theory.
Oh, okay.
Which comes in play in physics. Because physics essentially is chaotic. If you actually delve into physics, it's very chaotic. There's a lot of fields in mathematics that you would never think of. For instance, game theory, you would never think of that as a math, and it is.
Does that game G-A-I-N?
Game.
G-A-M-E?
Yes.
Okay. Poker or something?
Yeah, you can study best method of winning. This is essentially what game theory breaks down to. Counting cards in blackjack is a game theory problem. I've studied it. No, I will not pass it on for 2 reasons. 1, it's been so long I forget it, and 2, it's frowned upon. While not technically illegal, frowned upon. But in math, game has a different definition as well. Right, so we make a conjecture, or sometimes it's called a proposition. Right? If you study advanced math courses, they will interchange conjecture proposition with theorems a lot. They usually use it to represent a lesser theorem. Right? So typically in class, when we say theorem, we mean it's like a very important result. And they'll say like propositions to be less important results that are useful in proving your really big result. But just technically speaking, a proposition is unproven. It's something that you conjecture. So we make a conjecture and we go, okay. I'm going to use B sub n here, because we've been saying A sub n is the entire collection with the x minus x naught to the n included. So consider this power series. And we conjecture that the radius of convergence is just 1 over rho, where rho is the limit of the absolute value of the ratio of terms. Right, so this would be a conjecture. And then what you would do is you would then try to set out and prove it mathematically. Right, so you notice a pattern, you make a conjecture, You prove your conjecture, and then you publish it. Well, publish is the wrong word. You don't actually, you send it into the math community to review before publishing. Right? And typically, the math community wants to prove you were an idiot. So they try to actually find holes in your proof. We're not nice people. Not at all. Scientists aren't nice people either, by the way. They always want to claim you're an idiot. So they always try to prove you wrong. That's actually how a lot of discoveries are made. They're made by accident. They're not set out to be made on purpose. It's actually how alcohol was discovered. A group of Irish scientists, I forget what they were trying to do. They were doing something and accidentally fermented. And now we have alcohol. And that is why the Irish are stereotypically considered to be drunks. A stereotype I am more than happy to live up to. Or down to, I guess. Also, interesting fact, St. Patrick is not Irish. And his color wasn't green. It was blue. So St. Patrick's Day is a lie. By the way, this conjecture is proven. This is true.
Okay.
I'm just not going to prove it. I don't know if I proved it in the video. But this is true. So if all you want is the radius of convergence, that's all I'm asking for, that's how you can find it. We're looking at this series. We can simplify it a little bit. Just to make it more explicitly alternating. Does this converge or diverge?
Average.
Why?
This energy is like this.
Why?
Because 4. Present 4.
You're right, the limit is not 0. But why is it not 0? So you could physically go in and calculate the limit. It's not infinity. You could go in and actually try and calculate that limit. Have fun doing that by hand. That is not a fun limit to evaluate by hand. And by hand, I mean algebraically, analytically. You could graph it. That requires technology. You could also use a calculator to evaluate the limit. Again, that requires technology. Or you can just examine it. Look at just this term here. 4 to the n times n factorial squared all over 2n factorial. Now remember, we're letting n get very large. Yeah, that n factorial squared completely dominates the numerator. That 4 to the n doesn't even bloody matter. 4 to the 1 millionth power versus a million factorial and then squared. A million factorial alone dominates, right? 4 to the 1 million is nowhere near a million factorial. Now we're squaring it on top of that. So that 4 to the n doesn't matter. Compare n factorial squared to 2n factorial. Again, a million factorial squared versus 2 million factorial. One million factorial squared completely dominates. Again, it's not even close. Which means that this limit goes to infinity. But it alternates. So the magnitude is increasing without bound. And then it keeps jumping positive to negative, positive to negative, positive to negative. The limit does not exist. And then, of course, because you really shouldn't believe me, this is something I haven't seen in a while. So I actually just discovered they updated the free account. You actually now have unlimited saves. It's just they delete after, I think, 30 days. So you can only store files for like 30 days for the free account. But you can still download the file, which is actually really cool. So let's magnify 200%. Let's quickly change the name. Limit. I'm ignoring the -1 to the n because I'm not sure. I actually think it will handle that. Four to the n times n factorial squared all over 2n factorial, n goes to infinity. So our observation was correct. That limit is infinite. I'm going to see if the cloud can handle this, because I know the desktop version does. Nice. Yeah, it gives you something in terms of complex values, which means for us, does not exist. If we now do x equals 4, We don't even need to do any kind of simplification there. We already know what happens. We already examined that limit when we were looking at this. That limit's infinite, which is not 0, so it diverges by the divergence test. Makes the interval, the open interval, -4 to +4. See that? Questions on interval of convergence, radius of convergence.
How would you find the radius other than look at the reciprocals?
There's no other way. You have to look at the limit.
Right, but how do we find it before we realized that they were reciprocals of each other?
By the definition of interval of convergence. Right, the interval of convergence is your center minus the radius to the center plus the radius. Right, so in other words, even if we look here, right? Oh, not that one. Absolute value of x plus 1 less than 1. Radius is 1.
Okay.
Absolute value of x minus pi less than 3, your radius is 3.
So whatever the absolute value
Is less than, that's your radius.
Okay, is it always the positive version?
Radius is always positive.
Okay, yeah.
So yes.
Okay.
So a good way of thinking of it is right, you have your number line, your interval for the power series. This would be the x naught. The radius is how far out from the center can extend, like a circle.
Okay.
All right, so let's say that is it. That distance is your radius.
Okay, so the radius would be whatever the absolute value, less than equals
Is less than. That's your radius.
Less than after you made sure that the x would be 0. So in other words, if it
doesn't have to be 0.
Okay.
X naught doesn't have to be 0.
Oh, okay. So if this started at like
right, which is why again I looked at this one. Absolute value of x minus pi was less than 3. 3 is your radius. Right, so whatever the absolute value of x minus x naught happens to be less than, that's your radius.
Okay.
You could also look at it here. Right, x is between pi minus 3 and pi plus 3. What was the radius? 3. Right, because the center was pi. So how far away from pi does it extend on each side? 3. Right.
Okay.
So it's 3 units away from pi on either side. That's your radius.
Okay.
So let's try finding a power series. X over 1 minus x squared. So here's the general idea without using the technique that we're going to study on Monday. That kind of resembles 1 over 1 minus r, doesn't it?
Yeah, except something.
What does that equal? Because that should look familiar from our study of series. 1 over 1 minus r.
One of the things we talked about the last class.
It's towards the beginning. Should have been April 3rd. So while we're looking for that, do you have the science one? What kind of series is that?
Geometric.
When does it converge?
When the absolute value of r is less than 1.
So start one over 1 minus x. Well, that's geometric. Valid for absolute value of x less than 1. So that would be the interval of convergence, -1 to +1. Well, how could we get 1 over 1 minus x squared then?
If r is minus x to the n.
Actually, 2n.
How'd you get it?
Just no.
Just replace x with x squared, right? That'd be valid for absolute value of x squared less than 1. Right, so x to the 2n. If the absolute value of x squared is less than 1, what's the absolute value of x less than?
1.
Still 1. Well, how do you think we're going to get x over 1 minus x squared?
Is our C? Yeah. Can our C be X?
Yeah.
In a sense, that's what's going to happen.
Yeah.
So look at it this way, because you're not always going to have geometric. How do we go from 1 over 1 minus x squared to x over 1 minus x squared? What did we do?
Multiply by x.
So take our series and multiply by x, which for geometric is c, right? What is x times x to the 2n?
X 2n plus 1.
There's your series expansion. And remember, you have to include an interval. So it wouldn't be good enough on a test just to give me the series x to the 2n plus 1. You wouldn't get full credit. You'd have to tell me where that expansion is valid. Okay, so one more. I'm going to write it up here. Actually, no, I'm not. I'm going to do it down here. How should we proceed?
Would be 3x to the n, wouldn't it?
Can we like expand 3 into like 1 and 2 to make it 1 minus?
Then you're going to have that extra 2 in the denominator.
So
Technically you can, but it's not going to help you. Well, first, it seems obvious, but just flip the order. Right, it is 3 plus x instead of x plus 3. But we want it to be minus, right? We want 1 minus, don't we?
Yeah.
How can we make that 3 a 1?
Divided by 3.
Factor out of 3. What I'm going to do is write it as factoring out of 1/3. What does negative x become if we factor out a 3?
Yeah.
What is it?
Negative 1/3 x.
We have the 1/3, and we're going to know the power series for this. Right, we know 1 over 1 minus x is going to be x to the n. But we have 1 over 1 minus negative x over 3.
So negative x over 3 to the n.
For absolute value of negative x over 3 less than 1. Keep that 1/3 out there for now. Just thinking about, I'll keep the x to the n in the numerator. It's fine. Just make it look more like a power series. If the absolute value of negative x over 3 has to be less than 1, what about the absolute value of x?
Does that have to be less than 3?
Less than 3.
Yeah.
And now just pull the 1/3 in. And there's the power series. See that? Right, so say we're given a power series. That's a function, isn't it?
Yeah.
What was the first thing? Oh, I guess the second thing that you studied in Calc 1.
Limits.
That's the first. What came after limits?
Like after the whole unit of limits? Derivatives. Yeah.
You can take the derivative of a power series, which is important because you'll be seeing this again in differential equations if you have to take it. But the derivative, it's linear, right? Derivative of sum of the derivatives. Derivative of a scalar times a function is the scalar times the derivative of the function. Well, this is just the sum of a bunch of terms. So you can pull the derivative inside the sum. But that a sub n, does that change with respect to x? So does a sub n depend on x at all?
No.
No. What is the derivative of x minus x naught to the nth power with respect to x?
It would be 1 minus, oh, it's 1 naught.
Remember, x naught is also a constant.
Oh, so that would just go to 0. Would be oh, those both constants?
No. X is not constant. X naught is a constant. It's the center.
So to the nth power.
So the whole thing's being raised to the nth power.
Would you be able to use the power rule on it?
What does power rule say?
That you would be n minus 1. No, n. It would be n in front, and then the equation then notes the power of n minus 1.
Because the derivative of x minus x naught is just 1, isn't it?
Yeah.
So chain rule will just give you 1. Where do we start? N equals what to infinity?
0.
0?
1.
1. If n is 0, you just get a sub n, right?
Yeah.
What's the derivative of a constant?
0.
You lose a term when you take the derivative. That's why n now starts at 1, because you've lost a term. What came after derivatives?
Integrals.
You can also integrate a power function. We don't study definite integrals. Because they would be a pain to deal with infinite sums. You can do it, but we're not worried about it in this course. Integrals are also linear. That a sub n is again constant. What is the antiderivative of x minus x naught to the nth power? We'll do the simple antiderivative. Right? Because remember, when you take an antiderivative, you do get a constant of integration at the very end. So c plus, and then whatever the simple antiderivative is. So what is the simple antiderivative of x minus x naught to the nth power?
Would be the equation x minus x naught over n raised to the n plus 1 power.
Close. So again, the derivative of x minus x naught is just 1.
Right.
So you can treat it as u. So what's the antiderivative of u to the n?
Antiderivative of u to the n would usually be, we can't use the power one now.
Why can't you?
So wouldn't it be, I think it's n, let's say, would it be u over n plus 1 to the n plus 1 power?
So be careful. Because the way you said it, you're raising the entire fraction to the n plus 1. I don't think that's what you meant.
Okay, so u to the n plus
Yes.
1 power over n plus 1. So the bottom has to be n plus 1 also.
N goes from what to infinity?
1.
Why 1? You didn't lose a term this time, did you? When you take the antiderivative, it doesn't take a term away. It adds a term in, right? But that term that's added in is this constant of integration, which is outside the summation, which is why you still start in 0 to infinity. So yes, you can take derivatives and integrals of power series. They're still functions. Specifically, they're polynomials. Right, just infinite degree polynomials. Questions on anything we've done this evening? The final collection of my math assignments are due on May 8th. Remember, that's the day of the final. Third discussion, is it the final? Also happens to be the last discussion question, is up. The initial post will be due on the 19th, which is Friday. Replies will be due on the 22nd, which is Monday. On Monday, we look at Taylor series, and actually that's the end of series as well. Taylor series, and then we move on to analytic geometry for the final 2 weeks. Have a great evening. Have a great weekend. I'll see you all again Monday.